Anyway, so this talk is a replacement talk. Again, all apologies, Mike Slynn wasn't able to present today. So I'm going to give a quick talk about what you need to know about Lambdas in order to do them right. So I am Jamie Allen. I'm the Director of Consulting for Typesafe. I've been working for Typesafe for, 15 months now. And I've been programming with Scala since 2009. So I've been doing a lot of work with actors and functional programming, and I've learned a lot of things about ways you can shoot yourself in the foot, especially when you're dealing with production. So I want to share some learnings about how to do them and not get into the positions I've been before. First off, I love functional programming. This is an important thing for me to say because some things here are going to be somewhat controversial. When I think of functional programming, I don't think of the Scala Z type of functional programming. That's a way to do functional programming. It's a mechanism for doing category theory through Scala, but it isn't functional programming in and of itself, at least to me. My basic definition of functional programming is the concept of immutable state, programming with nothing being mutable, referential transparency, which is the concept of you performing an operation over some data and not changing it by accident to get a new value. So the classic example that Runar Bjarnason uses is the string buffer inside of Java. If we use a string buffer to get a string value and then we say reverse on the string buffer, not only do we get a new value of the reverse string, but the string buffer itself has been reversed. This is not a side effect you probably wanted, and that's referentially opaque. We want to be referentially transparent. We don't want the data we're operating on to change. And then finally, functions as first-class citizens. We want our functions to be like any other type. They can be passed around. They can be used as a type itself. They're just normal things in our ecosystem. So that's functional programming to me. Now, what is a lambda? A lot of people don't actually know what a lambda is. All a lambda is a function literal. When I talked about a string, if I put my name inside of quotes, that's a string literal, right? A function literal is just a function that has not been bound to a name. No val, myfunc, equal a function. It's just, a literal that has no binding whatsoever. So that's good, you'd think. Maybe it's not, but it's merely an implementation detail of functional programming. You can do functional programming with first-class functions and never touch a lambda. It's entirely up to the way you want to code. So here's Java 8. I spent a little time playing around with Java 8, and I tried to figure out how they were going to be using lambdas. And it's better than what we were doing before in our imperative style, where we would have to define some collection that we were going to put values into, and then we do a for each, and we'd maybe do a filter to figure out which ones we want to go into the new collection, right? But it's still pretty verbose. You have to do these imports because you don't have something nice like predef or package objects that you get in Scala to avoid this kind of extra stuff. You have to streamify your collection. See, first I'm going to create my numbers list here, and I'm just going to put 3 values inside of it. But to actually apply a lambda in Java, I have to do this stream call, which is going to allow me to apply my lambda through map, the map transformation, right? And then when I'm done, I have to manually collect them into the new list. It's not an implicit behavior like we get with Scala's map. You know that when you do a map, you're going to get back a new collection of the same type, right? You're going to get, if you were working with a sequence, you're going to get another sequence back. If you work with a set, you're going to get another set back. What's inside of it may be different, but you don't have to worry about this extra step here. But here's your lambda. It looks kind of familiar to those of us from Scala. It's not an equal arrow, it's a dash arrow. But, perfectly readable to anybody who's done Scala before. In Scala, the exact same code is slightly different. We don't have to have the imports, and we can use the object extending app to, start up our application. Just a list of 1, 2, 3, and then we map over them, right? And I don't use the underscore syntax here because usually when I'm presenting this, I'm showing it to Java devs, and underscore is confusing to them. Understandably, it's confusing to anybody new to Scala typically. So just so that everybody can understand what's going on for every number plus 1, right? Clojure. How many people are programming Clojure? Wow, okay. Personally, I like lists. You know, I don't mind writing scheme for things like doing SICP whenever I was learning that book. But the prefix syntax, where we are going to do prefix type operators, right? Prefix notation, where we put what we want to do before the actual operands, always messes with me. This is Clojure. It's very simple code. You may wonder why I'm doing a println here, when all I wanted to do was map over my values 1, 2, 3. Well, if I don't, it's lazily evaluated, and I don't get a result. So literally, I could put a println before and a println after, but I would never see this line executed unless I somehow forced it to evaluate. Interesting little detail about Clojure, but the syntax is not quite as readable as Java and Scala, but if you get used to it, a lot of people like it. Then we have JRuby. And JRuby's is actually pretty simple too. All you have to do to make your Ruby run in the Java, on the virtual machine, is say this require Java. And that's it. You can put perfectly normal Ruby inside it. And here I define my numbers 1, 2, 3, and then I have to do this collect do, and my lambda is right here with this n and n plus 1. For every n, add 1. Nice. So what's the problem? Why are lambdas painful? I have about 7 reasons why they're painful to me. First of all, they're not reusable. We're defining code that only lives at the call site, right? So it's got a limited lifespan, and later on, if we want to reuse it, we can't. Because it's only where we were using it before. It's not bound to anything that we can reference. Oh well. It's not testable in isolation. I have seen people write incredibly complex lambdas, multi-line lambdas that do all kinds of funny stuff resulting in a value. Great, how are you going to test that? You've got to call the method in which it lives, and then, all the other behavior inside that method is now called in as part of your test. It's hard to test just what the lambda is doing, right? Maintainability. How did we know what our lambdas were doing? We had to read them. We had to look through every line of the code that's inside of the lambda and figure out what it's doing. There's nothing in there that says this is a lambda to do X or foo. It's just read it and figure it out. I'd much rather be able to look at a name that tells me what's going on. Lousy stack traces. Anybody ever come into this? Whenever you're using a lambda, what do you see? What kind of information does it give you about that block of code? It's got to do this thing called name mangling because it doesn't know what to call it. There's no way for it to infer what the lambda is doing. So they literally call this in, compiler devs, name mangling. And it's very apt because if you have 15 lambdas inside of one source file, you're going to have a non-fun $0, a non-fun $n. And you have to figure out which one you're talking about. You have the source line number to point you in the right direction. What if you put a lot of functionality all in one line? You got to figure out where in that line the exception was thrown from. What part of it was the problem? So I don't like that code. I don't like that very much. Yay. Oh, remind me to touch my computer every day. Okay, so lousy stack traces. This drives me bonkers because I come into this situation all the time where people ask me for help. I don't know what's going on, and I go in and see the stack trace. I'm like, oh. And then usually it's a really big lambda they've written as well. So let's look at the stack traces. This is Java 8 as of June. And here's the code that I'm using to cause a problem. It's basically the same thing you saw before where I was going to get a number plus 1, but instead I introduced a divide by 0 because I want to make this blow up. And here you see the name mangling, lambda $0. The more of them I have in there, the more of a problem I'm going to have, but I also happen to find a bug. Line number's 1. That's not even remotely possible in this code because of all the stuff I would have to put around this. Like just the public static void main, that would be source line 1. So, they're somehow defaulting to a value here, and you know, they argued with me about this a little bit, Oracle, because they were in the audience when I presented this at Jack's Conf here in Santa Clara. And they said, no, that's not happening. And I showed them the code, and I ran it and showed them, and they said, oh. So then they had to go fix it. Hopefully it's done now with the next release. But this is unacceptable. You neither know which Lambda you're talking about or the line number. You'll never figure it out. But by the way, the stack trace. I'm sorry,
does it actually increment them though? Like if the
Yeah.
first lambda is index 0, then 1, then 2?
Yeah, because they're going to have to be like SAMs, right? So, here's Scala. Again, the code's a little more concise, but it's really not better as far as the stack trace goes. First of all, the stack trace is bigger. And you see here, a non-fun $1 means nothing. So at least we give you the line number here, Lambda Playground 23. That's useful. Clojures is particularly onerous. I mean, it just goes on and on and on. But a lot of that has to do with the lazy evaluation. But you do see here that the function has been name mangled to fn ___ 10. And you can see the line number where it occurred, sort of. It doesn't tell you the class that you might think. It says core.clj. That's not the class I wrote. But you can generally figure out where the problem went wrong. And also the top of the stack trace is reflecting the Clojure stack frames because of the lazy evaluation. JRuby, they actually do this really well. I was pretty surprised. Theirs is a very simple little stack trace. It just tells you where the problem was and what the problem, where the problem occurred and what the problem was. And as I understand it, this actually came from a lot of the problems they were having with users who were seeing terrible stack traces, and so they fixed it. This is a great job. It's also really difficult to debug. If you write a one-line Lambda, right? How many people were using, say, Scala IDE version 2? Or IntelliJ, like 10? Where are they now? They're 11 or 12, right?
12.
Yeah, maybe 11. Back then, you could put a breakpoint on your numbers map _+1, but it wouldn't take you through the iteration of the collection, right? That was really painful. And the only way you were going to be able to do that kind of debugging was to take your Lambda and make it multi-line. You know, brace, line of code, and brace, and then you could put a breakpoint on the Lambda itself, and it would show you the iteration because of the source line fidelity on the JVM. Now, both Scala IDE and IntelliJ have fixed this, thank goodness, but it's still not such a bad idea to put the Lambda on its own line of code, so at least you see the line number more specifically, and break out the code to be more explicit as opposed to a whole bunch of things put together, because then you know what part of it broke, right? As opposed to where in this big line of code. Some languages, Scala, use placeholders instead of names, you know, that underscore. Java just announced that they've reserved underscore for this usage as well, but they haven't said that they're going to do it specifically. They see some value to it, I think. They think that might not be such a bad idea. But then what do you get for your variable name when you look at it in a watch window? Name mangling. A. You know, who knows what they're going to call it? And you have to figure out which of your variables you're trying to talk about here. So you might know by type. That might be a good pointer to it, but you know, the more complex things you're doing in the Lambda, the harder it's going to be to figure it out. So, real quick digression. This drives Ruby people a little nuts. They call everything a Clojure. And in some respects, I could see how that's valid. On the JVM, we have the ability to close over anything that's final, right? This is a rule of Java and therefore enforced at the JVM. We kind of have to follow this in Scala as well. Our compiler can do some stuff for you. But at the end of the day, to close over a value, it must be final. That only means that we can't reassign it. It has nothing to do with where this is on the heap. We could change the value in the heap if this is somehow mutable, right? Just like the idea of making a new collection in Java final, but you can change what's inside the collection, right? So closing over stuff is generally dangerous, and this is what closures are usually referring to. Closures with an S, not a J. That means you're writing a Lambda, but it's closing over external state. And a lot of people will use the terms interchangeably. It's not that big of a deal. I'm not that wonky. But if you want to know the PLT, programming language theory difference, that's it. Whether or not you're closing over something. And in this case, instead of saying that I'm just using a number literal plus 1, I'm referring to a value from outside the context of the Lambda. I'm closing over it. So closing over state is dangerous. And in Scala, we have the ability to use lambdas in a lot of different ways. We can define a future with a lambda, right? We can give a future body that's a lambda just by saying future, open brace, blah, 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 end brace. Close over stuff, you have no idea when that's actually going to execute. That can lead to race conditions very easily. If you're using any kind of mutable state inside of a Clojure, think about what you're doing. Give it a real good think as to whether or not you want to be doing that. Referencing something mutable from outside the context of your Lambda. It can really bite you. So what is our solution? We want to maintain our ability to write programs in a functional style, but we don't want to get ourselves in all these troubles with lambdas. We could use named functions. Instead of using a lambda, we just bind the function to a val. Some name. Call it foo, it doesn't matter. So long as it has a name that you can reference and reuse and test against and put breakpoints in and it can't close over anything, that's a good thing, right? Sort of. Here's an example. Instead of using my lambda inside of my, what I get passed to the map, I'm just going to define it beforehand. Now, also, the way I've written this exposes something bad inside of Scala. It would be better for me not to be saying this add 1 to value with the underscore here, because this is actually going to evaluate differently than if I just said add 1 to value, passing the function by name and not referencing the individual value explicitly. Believe it or not, that has a difference, and I didn't even know that until I did this. Never thought about it, because I don't write code like this typically. I wanted this to be more clear to anybody looking at this, how the value was being applied. Lesson learned, don't do that. But what this ends up doing still, I'm sorry.
Why is that?
Because
what is the difference?
this ends up being like a new instance of a function applied every single time as opposed to one instance of a function. Yeah. Didn't know that.
So what's the correct thing?
No value.
Well,
and I think part of that also
it's not
is
incorrect.
I'm sorry?
It's not incorrect. It's just that you get another anonymous class there.
Less efficient.
Less efficient.
And here you see the output I get from this is still saying a non-fun. Even though I gave it a name of bad function in this case, why don't I see bad function here? In this case, this is specific to Scala as well. We have this concept inside of our compile code called scoping. And the scoping of our function means that it doesn't have access to its name somehow. And I pointed this out to our compiler devs and said, this is kind of a problem. And they're like, yeah. It's not the highest priority thing on their plate at the moment. Compiler speed optimization is, so. But, there's a workaround for it, so I can understand. Now, has anybody ever heard the term Eta Expansion? Yeah. All that really means is we're taking a method and lifting it to be a function. We're just saying that we want a method call, but we want it applied as a function to our higher order functions. So our higher order functions are things like map, flat map, filter, what's another one? Contains, right? Where you're saying something that allows you to apply a function to the values inside of your collection without using any of the category theory terms. We're using this lifting to just take a method, an ordinary method that meets the contract of what our function does, and apply that to each value. So, methods as functions. In Scala, if we use a method, we get some of the benefits we really wanted in the first place. The scoping rules that were showing that terrible non-fun stuff with the function value suddenly aren't in play. But we also have something that's a perfectly ordinary method that anybody knows how to read and deal with. Some people new to Scala can be a little confused by this syntax because they haven't yet learned the concept of a transformation from int to int, or int to string. While a function's type is defined by the input values and the resulting value, right? It can be confusing for people at first. If they're dealing with methods, they don't have to worry about it. It's just a method. It looks normal to them. And when we use methods as functions, what syntax should we use? Well, here's a case where I've still done a def instead of a val. What I've really done here is only changed the way this is evaluated. When is a val evaluated?
Whatever you ask for.
No, it would be lazy. A val is evaluated when we create a class. When we instantiate the class, vals are immediately evaluated as much as possible, right? A def is evaluated when? At the call set, yeah. So in this case, not only am I am getting what I want in my stack trace, but every time I call a bad function, I'm reevaluating to a new function value, which is expensive, more expensive than we need it to be. So it's probably not the way to go. In the case of, wait a second. Oh, another thing, def is not stable. That's what I'm saying as far as when you get the evaluation. But it's better to stick with our simple method syntax here, right? And then it can figure out, all right, well, first of all, if I have to do a lifting, I can do it once. And I get my bad function syntax as well. I don't have to see any kind of a non-fun business. You do see it if you look a little bit lower, but you didn't have to focus on that. And in this case, no, I still did this. I have to fix these slides. So the benefits. We can't close over variables except for things defined at the class level. You could still close over that. You probably shouldn't. Anytime you have anything at the class level, those are the sort of things that you have to worry about thread safety, right? You want things to be passed in. You want things to be local to the scope of any method that you're doing, as opposed to referencing something from the this of a class instance, right? It's a general good rule of thumb for thread safe programming. We want the internal variables, this is actually wrong. Internal variables aren't operands, not all of them. Some are passed in as operands. Others you can define inside of your method as local variables, the scope for that. In that case, they're only defined within the stack, right? The stack frame of our method call. They're not, they're values that might be on the heap, but the reference to them only exists inside the stack frame. That's good. We get better stack traces as we saw. We saw the name of the method we wanted. It's more debuggable because typically, well, if you put your breakpoint on the method call, you still get that iterating through it. Every time it goes to the method, you are going to see your breakpoint hit, as opposed to the older IDEs, which didn't allow you to iterate through or show the application for every single value. It's more testable. Not more testable than a function. A function is just as testable, a named function, but at least you can write all the unit tests you want against your method. Easier maintenance. You have names. You can give valid names to your function as opposed to people having to read through all your lambdas to figure out what they're doing. And you get reusability. So you don't have to be worried about being dry, repeating yourself. So keep Lambda usage for the smallest expressions. We all have to find our threshold for pain. Am I saying never use a Lambda? No, that's silly. If you're doing underscore plus 1, why wouldn't you? Who wants to define a method to do underscore plus 1? But anything that requires multiple lines or any kind of complex computation might be a good idea to pull that out. Be able to test it by itself at the very least. Language creators, including us at Typesafe, we've got to make this better. Really, I don't think that Java developers know entirely what they're getting into here. I got just sitting there and trying to do a flat map on, some Java collection that I had. I had a list with 2 lists inside of it. I tried to do a flat map and I got a type error that, I see Scala type errors all the time, and I guess I've gotten used to them. They suck. They got a little better, but they're still not great. I saw the Java one, I was like, holy shit, this is existentials and stuff like that. And I was like, oh no. Because the type system isn't quite as exposed to us when we're doing Java, right? We don't think about how object is the upper bounds. Paul Phillips was talking about this a little bit in his talk, if anybody saw that. Object being the upper context bound, or upper bounds of our type bounding. Well, Java developers don't think about that. They're going to start seeing it. I was a little surprised by that. And on top of that, what are they going to do when they start having to write multiples of them? Whenever I'm teaching, I always tell people, start with the for expression, right? And if it turns out that what you're doing is really simple, then maybe you can take it back to using just map, if you want. But writing a for expression is an easier way to think about composing your operations when you have multiples of them. And Java doesn't support anything like that. And they're going to find out real soon that they want to. That's it. It's actually a pretty short presentation. So.
Can you back up a few slides?
Yeah.
Is that a good example?
This one.
Yeah, cool.
Yeah, and don't do this.
I like that.
I'm going to rewrite this to have JavaScript inside of it now, if not, it's orange. That'll be fun. It's fun to just play around with Java 8, actually, and just see what they're doing. Anybody see the different things that they're putting in, like, defender methods. Now we're going to have, in essence, traits in Java. If you see Adrian Morse, he's the head of the compiler team, he's running around here today. He is more excited about these defender methods coming in and our ability to leverage that for how we encode our traits. It's going to be big for us because now the JVM will actually support what we've been trying to do. He's more excited about that than Lambdas. We have a unique problem, though. Anybody know which platform, Scala is currently targeted at? Java 1.6. When do we make the move to Java 1.8? Because when we do, we're not exactly going to be able to support 1.6, 1.7, and 1.8. At least we don't have the resources of Oracle. So it's going to be really difficult for us to say when we retarget. We've been asking the community, finding out what people said, and most people are like, just stay on 1.6, please. Okay, but then we're still in those trade-offs that Paul was talking about, where we're doing round pegs and square holes. We want to be able to leverage some of the stuff that the Java platform is making. But we may not be able to if the community wants us to stay targeted at 1.6 and 1.7. So we'll see. No decisions have been made about, there was a talk about 2.12 being targeted at 1.8, but nothing's been officially decided. They also have optional coming, their concept of option. And initially there was some debate about whether or not they were going to allow mapping over an option. This concept of functors. Is it going to be allowed? Yeah, now they're doing that. They are actually going to support that in Java. That's nice. So you'll have defender methods, which are traits. You'll have optional, you'll have lambdas. They're really gunning for us. Yeah.
I didn't follow the Java 7 or Java 8 development much, but the first example you showed where you had to convert to a stream and then collect at the end.
Yeah.
I mean, why didn't they just add map to list? Was that? I mean, it seems like that's the obvious way to simplify that.
Yeah. I wasn't at the language summit, and I would have really liked to ask them this week. My guess is separation of concerns, that they really did not want to introduce the functional application of lambdas and functions to collections except through a limited interface.
Okay.
And you know what? Paul kind of alluded to something whenever he showed the 34 methods on sequence in a collection because of the hierarchy of the Scala collections hierarchy, starting at traversable once and working its way down. Yeah, he's not happy with that. And I think that's what they're trying to avoid here. So it's more orthogonal than it is in Scala, where Scala, it's a strict hierarchy, right? Throughout the collection system. Traversable defines the map, the flat map and the filter. And then all the collections have to meet that contract. There may be cases in collections where that's not relevant. I mean, some collections don't allow you to walk to next or anything like that, right? So they kind of have to do that, like hash set, right? What is next? There's no order or anything like that, right? So, you know, it may be questionable in the way we've done it, and they may actually have the better answer. And another thing is maybe they're not changing the API of the existing collections, you know?
Yeah.
So.
Yeah, I'm just wondering if it's something that they're going to add in 1.9.
Yeah, I don't think 1.8 is going to be the really interesting release. I think 1.9 is going to be, I think Java 9 is going to be really interesting to see what they do to clean up what's going to happen here. Because this is going to be a case where they're just going to drop a bomb on the Java community. And I'm not sure it's going to be adopted. I don't know. It's going to be interesting to watch. You know, is Java 6 the Windows XP of Java platforms? It might be. Especially with Red Hat now saying that they're going to continue supporting it in lieu of Oracle, right? So,
yeah, I mean, I know people who like Scala as a Java++, likes people like C++ as a better C. So this functionality going back to it kind of, to them they see it as like, oh, maybe I'll go back to Java now.
Maybe. You know, I don't know. We're not particularly worried about it.
Yeah.
At Typesafe, we think it's going to help people understand the concepts we've had in our language for a while. And that might actually improve our market, where, you know, more people are going to be adopting it because they understand them better now. But we also think we do a lot of other things really better. Like, they're going to put completable future into Java 8, maybe. I don't know if it's guaranteed. This is another thing Doug Lee is working on. Where you aren't going to have the blocking future, right? In Java right now, you have two interfaces to get the values out. Get and is done. And get is what you use whenever you've got one future you're running. Is done is what you do with a busy spin to figure out if your multiple futures are done, which one's done when, and when you can start moving off and doing work based on that, right? You know, we've had fully asynchronous since SIP 14. You know, that's ported back to Scala 2.9.3, so that's exciting. We think it is, and we'll see if that sort of thing is the innovation Java can catch up with.
Well, Java 8 is also getting implicits, right? I'm kidding.
Yeah, I was going to say that. Yeah, you know, there's a whole bunch of little things that inside of Scala we disparage. And, you know, things like implicit parameters, you know, Java's going to try and do things, and they're going to find out they're going to have to be extremely explicit up front and have very long parameter lists to support the functionality of distributing work across threads and timeouts and stuff like that, where, you know, we allow you to sort of say up front, you know, how you want it applied, you know. I don't really know how this is all going to shake out, but I'm not terribly worried about it. Java 8, fun. Java 9, that's going to be really interesting. So, and they were worried. Oracle was a little concerned about me giving this presentation because there were a whole bunch of them at JaxConf, and they came up to me and said, hey, you know, can I see your slides? Because I'm not going to be able to attend. Got to run back to the main campus and stuff. So, yeah, sure, you know. They didn't disagree with anything I said. And I think they do want people to hear some best practices. They're going to have lifting as well. They're going to take methods and lift them as functions. So, that's good. But yeah, they know that this is a big marketing push for Oracle. They're really trying to get the community excited about it. They really don't want people running around saying, this sucks. Which I'm not really doing. I'm just saying there's better ways to do it. All right, well, thank you.